What's up, class? Evans here. Sorry I'm not with you today, but I will be with you tomorrow. And I want to teach you today about dial calipers. They are an interesting precision tool that engineers use. Dial, because they have a dial right there. So let's dive right in. Don't forget to do the attendance check-in, by the way. So for your notes today, you're going to need a sketch like you see there, just kind of a basic sketch. This doesn't have to be complicated. I'll show you an example. You can click on here and see yourself. And this is what I have drawn in my notebook, something simple of this thing right here. Dial calipers are a unique tool that allows you to measure something down to the thousandths of an inch. That is thinner than human hair. So this is something that is very precise as a tool. And of course, there are other things that are even more precise than this, but this is a very common tool used by engineers. If you want to print out this, by the way, there is a printout clickable here. So let me scroll down to the slides and start with your sketch. So if you're watching this video, pause it, do your sketch, and then come back. So dial calipers are arguably the most common and versatile of all precision measuring tools used by engineers and manufacturers. Very commonplace and very precise. There are 4 measuring types, which is why I want you to have arrows drawn. Get things for their outside diameter or object thickness, inside diameter or space within, step distance, and hole depth. So a standard inch dial caliper with will measure about up to 6 inches or more, roughly. And let's go right into how they measure. One is outside measuring faces. And this is a measurement made between these 2 dial caliper faces. So I could take something like my ring here, and I could measure the outside of that ring. And then I could read the dial, read the ruler on here, and get a very accurate outside diameter of something. So again, that's used for measuring the thickness of objects or outside diameter of objects. So I'll put those definitions down with it. Here's an example, measuring the thickness of that part. Inside measuring faces, we have these little spikes at the top of it. And that would be to get like the inside measurement of a pipe, or like this ring of mine, my wedding ring. That can give me the inside diameter. So outside for these larger spikes at the bottom, inside for these upper spikes. That's inside measuring is what we're getting there. So that's would be like an inside diameter, or like a slot or something like that. This one's a little bit less common to be used, but if I have a part that has like some steps on it, or a step down or something like that, I can use the back surfaces here to place it on the back of it, and like lower this part down and get a measurement between the height of 2 surfaces. So this is an example for 2 stepped parallel surfaces, as shown in this illustration. As shown as this illustration right there. The last one is depth measuring faces, which is for this part sticking out of the back here. As I move this wheel here to extend it, the back extends further. So I could use this to measure the depth of an object. So if I have like an object that has a drilled hole in it, I could extend this down to the bottom of it and get an accurate measurement of that depth. Or if there's a slotted piece or something like that. Here's an example here. Now, to just kind of describe the different parts of it, we have the main slider part that goes back and forth. This is called the blade. slider up in here. This ruler part here is broken down into 1/10 of an inch, and then the dial breaks it down into the hundredths and thousandths of an inch. Your reference edge is visible here, should be pronounced feature. And then there's a little rack gear in here, which a rack gear is just a linear gear that has a round gear that moves back and forth on it. Accurate dial caliber readings require several steps, and they're not complicated. Step one is to make sure that everything's lined up. Sometimes these things get out of place, so you can turn this knob here, and then you could rotate the dial to match 0 underneath the actual needle when it's held closed. Once you get it on 0, then you could retighten this knob, and it should be accurate again. There is also a knob here at the top that can lock it in place so that you can take time to read it. Each time the pointer makes a complete rotation, that needle makes a complete rotation, that is moving down the ruler 1/10 of an inch. So once it spins 10 times, that means it's opened up the length of 1 inch. To determine the outside diameter of something like this, we need to look at a few places to read. So step one is it's over an inch. So you're going to get 4 numbers from dial calipers. A whole number, and then the decimal place, and then 3 numbers after that. So you first start with the whole number. We see here that it is over an inch. So your first number is 1. Of course, if it was before that, then your first number would be 0. So it's 1 point. And then we see it's at the 0.4 inch mark there on the ruler or the blade. Then we see on the dial, it is sitting at 37. So that'd be 0.037. We'd add all those together and we would get, of course, you can do your little estimate part too. So how far past the needle, you can do that and do a 4th decimal place, which would be the 10,000ths of an inch. Some high accuracy that you're estimating. So ultimately, it comes down to 1.4371. Of course, 1.437 is all I'm looking for from you right now. It's just be able to read it to that measurement. How wide would this block be? So I'll give you a second to read and get your answer. Okay, you should have 1 inch, and then it on the dial is past the 0, so that means it's reached the 4, so that's 0.4, and then 0.002, not 0.02 because that would be 20, but 2 zeros. So then our answer is, and then they estimate 0.0002 over would be 1.4022. Of course, that second 2, I'm not looking for that. I'm looking for the base reading for you. Now that's dial calibers. I want to go over in more detail with you tomorrow about these, and I'll try to measure even live of a couple of items, and I think it should be kind of fun and enjoyable as you see just how interesting this tool is, and I think it's kind of fun to use. So wish I could hand them to you, but we're not here in person, but you'll get to use them over the camera and learn how to read them correctly. And I'll see you guys tomorrow. Bye.